Welcome students. Today we are going to see the lab program 3, that is implement an Ethernet LAN using N nodes and set multiple traffic nodes and plot congestion window for different source or destination. So what is the question? What it is saying actually the question? What is the meaning of that? You should have the LAN connection. That is the first thing. You should have the LAN connection. Then what the next? As per the question, you should have N nodes. So the number of nodes you are going to design. Okay, how you want the nodes. So before going towards your programmatic sentence, first we will design our diagram. Okay, as it has told that there should be N nodes, so something it will come to your mind that okay, how many nodes I can take. You can take 2 nodes, you can take 4 nodes, you can take 100 nodes. That is depends on you. How many nodes you are taking, you have to specify in your program. First, let's see the diagram. Suppose I have drawn my diagram in this way. You can see how many nodes I have taken. I have taken 1, 2, 3, 4, 5, 6. So I have taken here 6 nodes. That is my choice. If you want, you can take 4 nodes also. That is not a problematic thing. Next, what we are going to do? We have to see that the nodes, if it will be 6 nodes, we need to start the nodes from N0 to N5. So here you can see N0, N1, N2, N3, N4, N5. So there are some 6 nodes. So if I want to do the 6 nodes, I have to decide which node I will take as source node and which node I will take as your destination node. That is also your choice. How many source nodes you are taking, how many destination nodes you are taking, that is also your choice. But whatever you will write here as in your diagram, whatever you will mention in your diagram, the same thing you should write in your programmatic way. That only one thing you have to take care. Okay, so we are very clear about that now. Here, as per this diagram, let me take N0 and N2 are my source node, N3 and N5 are my destination node. Okay, so this is I'm very clear about this. So what I will do, let me take one more, like I told you that I need to explain you through my one more wordpad I will open. So I will tell you how we are going to write all these things. Fine. So here I have taken how many nodes? I have taken, I'll just increase the font size so that you can see it properly. It should not be a problematic for you people. So I have taken, I told you I have taken 6 nodes. So here I will write N0 node, N1, N2, N3, N4 and N5. So now I have 6 nodes. What all are my source node I have taken? Let's go back to here. Here you can see I have taken the source node N0 and N2. So let me write down that here in my here. Okay, so this is my source node. I will write the source node here and here N2. Sorry, here. Okay, I'm writing here my N2 as source node. So now these all are my source node. According to the diagram, what all are my destination node? N3 and N5. So I will write here my N3 and my N5. So N3 my destination node and my N5 is also the destination node. If you people want, you can do the diagram along with me. It will be easy to understand also. So now these all are my nodes. I have specified my source node and my destination node. And please do the diagram also along with me. It will be easy for you to understand. So already my diagram is here, so I'm not repeating the diagram. So now one more thing is, as per the question says that everything has to be connected with your LAN connection. So how I'm going to specify my LAN connection? This line, whatever you are seeing here, this is my LAN. So what I will do? I have to connect all my nodes to this LAN. So which LAN I have, which nodes I have connected, that is also your choice. Which all are the nodes you want to connect, how you want to design, that is also your choice. What I have done, you can see as per the diagram, I have connected to the LAN my N0 node, you can see direct connections, N2 node direct connections, N1 node direct connections, N3 node direct connection, N4 also direct connection. But N5 I have not connected directly to the LAN connection. If you want, you can connect also, that won't be a mistake. But what I just made little tricky to this program, what I did is I have just made this N5 connected to my N4 node. So here, and the double line you are seeing, that is nothing but single line connection. Another line, the packets are moving actually. But in this diagram, it is looks like double line. But the second line is nothing but the packets are moving from N4 to N5. So here, this is my diagram. So now let's go back to the program. We will see how we have written the program. Here you can see what I have done here. First you have to set your simulator. So I have set my simulator. Next is what? So you should write the simulator object is ns. So set ns new simulator. Next, what you are going to do? You have to do the tracing file. You have to open, you have to give the file name here. So let me take this file, the third program file name. Suppose I have taken lab3. Okay. So here my tracing file name will be lab3.tr. The same file name you have to give, and here it is in the writing mode. Next, what I'm going to do, you need to trace all the contents, because dollar will help you to have all the contents of the file. So the contents, whatever is there inside your tracing file, it is going to switch over to your ns file, that is network simulator. Why we have used this new keyword? New keyword we have used to create the memory locations. So now we have shifted all the contents of TF to your NS. Next, what you are going to do? I told you that this like PCL program, always it will have the animations. So animation file we have to keep in the extension name of .nam file. So I have to create one more file name. What is my program file name? lab3. So I have to create my animation file name as lab3.nam. What I'm going to do, I will save all these nam files inside this nf. This nf is nothing but it is known as your object of your animation file, and it will be in your writing stage. Okay, so now what will be the next one? You can see I'm tracing all the nam file contents, whatever is present in nf. I'm just switching over everything to your ns. So this is the normal part which you are going to continue in all your programs. Next, as per our diagram, we have created this many nodes. Now we have to create these nodes here. So how we are going to create? You can see set n0 ns node. So n0 node created. Here set n1 ns node. n1 node created. Set n2 ns node. n2 created. Similarly n3 and n4 and n5 node created. Next, what we are going to do is the extra lines, whatever you are seeing. If I will move towards my diagram, you can see I have written here source 1, src 1, src 2, destination 1, destination 2. So I have written here. Okay, so that if you want to name these things, this node, that also you can write. These things are your decoration of your program. But if you will not write, it is also fine. Your program will run. And also you can see here this destination 2, it is in a square box. So that also you can write in your program. And if you want to give some colors, here the color has not come. in this picture, but actually we have given some colors. In originality you could have seen that. So that color also you can specify in the program. So how we are going to write all these things? I have given my first node the color. You can see the spelling of color, color, of magenta color. So I have given, and what I have labeling it, I have labeled it as my source 1. Okay, so that whenever we will like anyone else will see the diagram, they will understand which one is the source node, which one is the destination node. But for n1, I don't want to note anything, I don't want to label anything, so I have not given any name. But if you want, you can give. Similarly, for n2, the color is this and label is source 2. For N3, color is blue. The colors will take, there are some 256 colors starting from 0 to 255. Whatever the color code you want, you can utilize all the color codes. And here there is N3, color is blue, labeling is destination 2. But for the N4, I have not done anything. So for N5, there is a color of blue. Okay. So in this way, I have done my creation of the node. What we are going to do the next one, I told you that we have to connect all the nodes in a LAN connection. So to connect all the nodes in a LAN connection, what we are going to do is we have to utilize the keyword as make LAN. Okay, so you can see what all are the nodes we have connected. I told you that instead of N5, the rest of the nodes has been connected. So here I have connected, what all are the nodes I have connected to LAN connection. Within the double quote I have written, that is the syntax to write with the space. So $n0, $n1, $n2, $n3, $n4. What will be the speed? The time. So 100 Mbps and the 100 MB, and the time will be 100 milliseconds. So within that time period, they are going to transfer the packets. Now, what is a new one here? That is LLQ. What is this LLQ? I'll just briefly explain you about that LLQ and also about this MAC, how it is going to work. What is the meaning of this? If you want, I can tell you one more thing also. Here you know that this LLQ, okay, if I will take it as your LLQ, what is the meaning of how you are going to use? This is nothing but link layer queue. So when we are going to utilize this? Normally what will happen, we have the network stack, okay. In that network stack, there are many things will be present, and where we are going to utilize all these things, we are going to use in our mobile node. What is that mobile node? Now that you will come to know in your next program clearly, but for the timing you understand that in your mobile node there will be network stack. Okay, so all varieties of network things will be inside. So what all are that network stack? One is your this LLQ, that is link layer queue. One more is also there, that is nothing but, I'll just write down here, that is nothing but ARP. Okay, and what is the next one? Next one will be your MAC layer. Okay, so all these things are nothing but, these all are present inside your LLQ. Now you can ask me, what is the work of them, what they are doing actually in that. So what will happen is, all these components like LLQ, MAC layer, ARP layers, all these things will be plumbed together, okay, inside this TCL. So whenever we will move any packets from one place to another place, they will just pass on the packets from one place to another place. So they will help us to pass the packets from one place to another place. Now next question will arise, when they will pass the packets. Okay, suppose if we have the outgoing channel in the sense, like normally if we are getting any kind of packets from outside, okay, which is not connected, that time what will happen is, that time this LLQ, whatever is there, what will be the job of this LLQ is, it will just accept all the outgoing packets and it will forward to my agent. What kind of agent? Here I have written the agent. These agents are nothing but known as your routing agent. They will help that in which way your packets are going to move. Okay, so from outside world it will accept the packet, then it will pass to this agent. Now what this agent will do, this agent will pass this packet again to the network stack. Again, one more thing also there inside your network stack, that is nothing but that is your interface queue. It will be better if I'll write down over here, you will understand. The first concept will be your network queue, sorry, network stack. Okay, so inside this network stack, the first thing will be your LL layer. Okay, so link layer. Next one will be your ARP. So next one will be your MAC. Okay, next one also interface, that is interface queue. Interface queue. Okay, so now these things will be there. If I am considering about the outgoing channels, if you want you can write down. If I am considering about outgoing channel, that time this LL, what it will do, it will just pass all the it will accept all the message packets. Okay, and this LL will forward all the packets to your routing agent. Whatever the routing agent will be there, it will pass there. So that what will happen, it will just give the way where is the shortest distance and all, and it will pass that message to or packets to that channels. And once it will send to the routing agent, then again this one, this LL, what it will do is it is going to like hand down all these things to the interface queue. Once it will be done, next it is going to send these packets to interface queue. So this is a procedure, you have to remember the procedure. Okay, next one, if suppose it will be incoming packets. Okay, the packets which all are moving inside your channels, so that is known as your incoming channel. So if there will be incoming packets, so how you are going to handle that? That time this MAC layer, okay, whatever the MAC layer is there, he will send the packets to my link layer. Okay, then link layer will send all these packets to my node entry point. There will be one node entry point. So this is nothing but this is like your way of transferring the message. So now we are going to consider this incoming incoming channel. As we are considering this, we are using this MAC and LL. You can see in your program what is happening. So it will, the MAC layer will accept all the packets and it is going to put everything inside your LL queue. Okay, so and one more thing you can ask me, what is this? This is nothing but these things comes under your IFQ, interface queue. Okay, so this interface queue is nothing but whatever I am writing that drop like a drop tail. So this is nothing but your, it comes under your drop tail values, queue and drop tail values. I hope you are understanding. So that's why these three concepts we have written. One is link layer, one is IFQ, one is MAC. And this is nothing but, this is your IEEE. You are going to implement on this, okay, 802.3 or 802.11. So you are going to implement this. In this way, you have to connect the LAN. So whenever you are going to transfer the packets, it will transfer to MAC, then go to here, then go to here. And the next one will be, as I told you that you can see the diagram also. In the diagram, the N4 has been connected to your N5. That connectivity we have not written. So in the program, that connectivity also we should write. How we are going to write? So that will be a duplex link. Why it will be a duplex link? Because the N4 can send the packets to N5 and N5 also can send the packets to N4 with this much of speed and this much of time. Then drop all the packets. So this is the connectivity we have done. Once the connectivity we have done, what is the next procedure? I told you that this program is nothing but it comes under your TCP program. So if it will be a TCP program, so before going to all these things, we should understand how we are going to give the connectivity. So here what all are my, first I have to, how I'm going to design this. Once I will write it in my rough note, I can make it as a programmatic way very easily. So I told you that this is a TCP program. So if it is a TCP program, then it will support the application of FTP. Okay. But in your UDP program, it was supporting the application of CBR. So here it will support the application of FTP. But in UDP, we have used the null values. But in TCP, we will use the sync values. That much is only the difference between TCP and UDP. Because TCP is a connection oriented protocol and UDP is a connection less protocol. So what I am going to do, first I have to notify who all are my source nodes. So this is my source node, first one N0. Okay, next one is my N. Here I can show you that this is my N2. So these all are my source nodes. First, you need to consider about your source node. So if I will consider about source node, I'll come to know that yes, how I'm going to use this. So now N0, I told you, as it is a TCP program, we need to connect it to my TCP 0. Okay. And N2, I will connect it to my TCP 2. This is nothing but object name. You can give anything, but if I will notify it as TCP 0, as 0 node, as 0, it will be easy for me to detect the TCP for which node it has been utilized. So this is my source node. So next what I'm going to do? Next, at this TCP connections, I have to connect it to my FTP. So what I will do, this TCP 0, I will connect, I'll just give a space over here. I'll write TCP 0 connect to my FTP 0. You can write in a other way actually, that is better, that practice. FTP 0 has to be connect with my TCP 0. Next what I'm going to do? Next I'm going to write here my FTP 2 has to connect to my TCP 2. So this is my connections. Next I told you that all these things has to be connected with your sync. So here my TCP, where it is going to connect? My TCP 0 will connect to my sync. So which sync you want to connect? Sync is nothing but your output. What all are the output you can see here? Yes, the destination node is N3 and N5. So you need to connect to destinations. Okay. So destination in the sense you can connect to anything. Let me connect this one to my sync 5th node. Okay. But and here I will connect to my TCP, this TCP 2 whatever is there, TCP 2 I'll connect to my, let's take it as sync 3, because these two are my destination node. But here I should write before that my destination node also. Here I have not written, I'll just specify that also so that you can understand this. So what I'm going to do here, my destination node was, what are my destination node? One is N3 and one more will be my N5. So as these two are my destination node, so always what I supposed to do? I supposed to connect it to my sync. Okay. So what all are the sync it has to connect? N3 has been connected to my sync 3 and N5 has been connected to my sync 5. So that things I have written over here. Okay. So I have given the connections from, this is my source node, this is my destination, this is my source node, this is my destination node. Only the thing is that in like directly it has not connected from N0 to N5. Instead of that, it has been connected through your TCP 0 to sync 5 and TCP 2 to sync 3. That is your choice where you want to give the connection. So now I have done this part. I hope you all have written this. Same thing we are going to write in the program. See here in the program. So we have discussed till here the connectivity. Now what I'm going to do, I have to create this TCP 0. I told you, right? Here you can see TCP 0, TCP 2 I need to create. I will create here. TCP 0 set TCP 0. It is inside your agent and TCP. Okay. Give the connectivity from N0 to TCP0. Next, what you're going to do, you have to connect with which one? FTP0 to TCP0. That also I have written here. First, you have to create that application is there, then attach this agent to TCP0. So this part over. So now what is the next part? You can see I have created TCP2 over here for my N2. I have created TCP2 here, connectivity to N2. Then I have created my FTP2 application. I have connected to my FTP2 to TCP2. So now what is this extra lines has been written? This is nothing but I have allotted some packet size. I have given some interval time of my first node so that within this interval time the next packet should move. Similarly, I have given for my next source also the packet size of my N2 node is 600 and the interval time will be this much. So once you have done with this, what is the next one? The source node has been connected. Now it is the time for your destination node. How you are going to connect your destination node? The destination node has to be connect. First you have to create sync 5. So where is that sync? It is inside your agent and TCP sync. You are going to connect it N5 to sync 5. Similarly, another destination node also you have to create, that is N3, and N3 you are going to connect it to your sync 3. And in the last sentence what I told, we need to connect to the source to the destination. That part I have written over here. So connect NS connect TCP2 to sync 3. See here I have done in my diagram TCP2 to sync 3. And here I have written. And what is the next one? Here also I have written everything. Here you can see NS TCP2 to sync 3. Here I have given NS connect TCP0 to sync 5. So here TCP0 to sync 5. So both the things has been written. It is not mandatory that you should follow the sequence also. If you want to write the proper sequence as per you, you can write. That is not a problem. Next, what we are going to do now, this part is little different. As we have two source node, so whenever you can see the diagram, I have given some of the packet size. So whenever the packets will start roaming from this place to here, it will also create one database where it is going to keep all the packets. Similarly, it will happen for your second source node also. Otherwise, the congestion will come. In the traffic, the congestion will come and the packets will get lost. So what we are going to do, so here you can see along with this, we need to create one diagram also, one graph. Okay. So how you are going to create this graph? Here you can see two graphs. One is in the green color, one is in the red color. So how you are going to design this? There are two files. This is the data, the red lines. This is the data from file 1. This is the data from file 2. That file 1 is nothing but the data has come from your first node, first source node. The green color, the file 2, the data has come from your source file 2. Okay, so you need to create two. As you have two source node, you are getting two graphs. If you will have 5 source node, you will get here 5 variety nodes. Okay, you can see here is something has written. The first one A1, second is A2. Red line is A1, second green line is A2. I'll show you how it is happening. Here you have to come. That part we are going to write. So what we are going to write? We have to create two files. Okay, file 1 and file 2. The data, whatever is coming from your TCP0, you can see over here, this TCP0 is nothing but your first source node. TCP2 is nothing but your second source node. So that connections I have given here. TCP0 attached to your file 1. So what will happen? It will trace some of the data in the writing mode and it will keep all these things inside your file 1. Now that contents of the file 1 is going to connect or it is going to attach inside in your TCP0. It means that is your first source node. Secondly, what is happening? Whatever the data are coming from, packets are coming from your second source node, that we are going to keep it inside the file 2. You are going to trace all these things, you are going to keep, and you are going to attach everything to your file 2. So now next one, what will happen? We have to trace the congestions. That is the first thing. How we are going to write that things? You can see this is my source node. This is second source node. You are going to trace congestion window, CWND. This is nothing but my congestion window. Okay. So, and after that one underscore is there, that you should remember. So both the congestion window, you need to trace it. Next, what is happening? Next thing is procedure part. You are going to globally declare all this NS, NFTF, flush trace the NS. If any contents will be there before to this program execution, you need to flush it out. Then you are going to close the tracing file. You are going to close the NAM file. Once this work will be done, you are going to execute your lab 3. Once till you will not write this sentence, your output screen you can see only, it won't start. Okay, because execution you need to write over here for all the programs. So how we will go to this NAM file? Here is the ampersand which will have the address of this lab 3. We will directly move towards this NAM file. Then this is the first, the cursor will come here, the compiler will come here. First this process will start, then only the next process will start. So you are going to exit it here. Now what is there? Now here we have written in this part. Here you can see the last line is NS run, when the network simulator is going to start. But at what time it will start? You can see 0.1, 5, 7, 0.2, all these things has been written. That is nothing but they all are the milliseconds time period. I have drawn one diagram over here. You can see now. So what I have done is, here some of the time periods are there. I have taken my timer. This is my timer line where there will be 0, 5, 10, 15 and 20. Let's check it out. So here what you can do, the FTP 0 is starting at 0.1. So what I will do is now, so FTP 0 will start now. Okay. So here this is starting. So now what you are going to do is, you can write down here. So now what I will do, I know that according to the program, my FTP 0 is starting at my FTP 0. I'll just make it a little bigger size so that you can see properly. Yeah. Okay. Is it fine? Yes, fine. Yeah. FTP 0 is will start in the time period of 0.1 milliseconds. I'll just write down here 0.1. So you can see it will start from here, somewhere here. So next it is what is happening? 5. At 5 milliseconds of time, the FTP 0 will stop. So it will move from 0.1 to 5. But you cannot say that in between that, one more source node will not start. That also can happen. That's the reason the congestion will always come. If one source node is sending the packets and in between the other source node is coming and disturbing that source node and sending their own packets, that time the congestion will create. So again you can see my FTP 0 got stopped here, but again I don't know what mood he got. Again he started sending the packets in the time period of 7. So here my packet start at 7 milliseconds of time, and within that time period my FTP2 started. Okay, so now when my FTP2 started, you can see the timeline, you can mark in the timeline FTP2 is starting in between 0.2. Okay, when FTP0 was running, that time FTP2 already started, and here FTP2 is stopping at 8 milliseconds of time. So it is moving like this. In between that, again FTP0. You see here, FTP2 has not stopped, but FTP0 started again. So till what time it is going to do? So it will start till your 14. Okay, because 14 only it is going to stop. So till 14. Next, what is happening? Again in the 10, FTP2, again it will start. Okay, because in between 8 it is stopped, then again at 10 only it started. So what happened here? Again, I don't know. Again, his mood got changed. Again, he started at 10 milliseconds of time and stopped at 15 milliseconds of time. So in this way, as they are overlapping with the time, you can say the congestion used to come. That's the reason we have traced the congestions. Then at 16 milliseconds of time, you finish it and it will start running. In this way, the program will start run. Now let's see how we are going to write the awk files. Every program will have the awk files. So how we are going to write? So here the awk file will be there. You have to begin, you have to end. Okay. So in between, what we are going to write, we should write about the congestion window, because whenever one source will start and within the same time period as I showed you here, if one more also it is starting, you can see 0.1 the source node has been started within very recently, like 0.2 only the next one will start. Then if in this case what will happen is definitely the congestion will arrive. So we need to calculate how many like no how many packets were got lost, or what is the situation of the congestions, that we are going to find out here. So here we have to write dollar sign 6, then the congestion window. So as I'm not wrong, the 6, the contents of 6, the field of 6 is known as your packet size. Correct, no? Packet size. Yes, I guess I am correct. Packet size. And what is the first one? Here we are going to retrieve the data of the field, whatever is present, that is 1. The content, whatever is there inside your 1, you are going to retrieve that things. What is there inside your 1? It will be the event whatever has been called, so that will be there inside your 1. And also I want one more field has to be called. What is that field? That is $7. What is this $7? The 7 in the, you can see I have showed you in the first day itself, we have the 12 fields. So in the 7th field there will be the flag. So it is going to have the contents of the flag. So it is going to show you the event type, and it is going to show you the flag. And if the 6 is the field name, which is known as your packet size. If the packet size is congestion, it comes under your congestion window, then it is going to retrieve this data. So these things you are going to write in your awk file. Now we will see the steps, how we are going to execute this program and how we are going to get the outputs. Whenever you will start writing your TCL program, first you have to open the terminal, you have to write vi space lab3.tcl, because all the programs are TCL program. So the extension name will be .tcl. You can see whole program, whatever we have written here, this all the program you need to write till run. You need to write under your vi space lab3.tcl. So here you are going to write. So you have written the program. Once the program written will over, you have to press escape key just to come out from that terminal. You have to press escape key, shift and colon, and then you will be outside of that window. You will be in your terminal. So next you have to open one more file where you are going to write your awk program. So what you are going to write? vi, the same program name, it will not create any problem, lab3.awk. So whenever you will write this, one editor will get open. That time you are going to write this program. So two programs in two different vi editor you are going to write. Once you have written, similar process, write, press escape key, shift and colon, wq, then you will just wq in the sense quit with the save, then you are coming towards your terminal. Once you will come to your terminal, to run your simulation program, you have to write ns lab3.tcl. You have to run your TCL program. Once you will write this, what you are going to see? You will see this diagram. So here, only if you will see the diagram, but if you will not press any of this button, you cannot trace the packets. You have to press the play button. Whenever you will press the play button, you can observe all the packets will start roaming as the marks over here. This one will be your timer line, timeline. And also here you can see that, and also you can see if you want to make it more speed or less speed, you can do that also. But you should press the play button. It has to run from here to here. Once it will run, it will find out the congestions and it will get the datas, the packets, and it will save inside your file 1 and file 2. But we don't know how it is going to keep it. For that reason, we should write again. You have to open. So what you are going to write here? You need to write over here. This is the, in your terminal only you have to write. You can see awk space minus f space lab3 awk space file1.tr. This file1.tr also we have written in the program. I hope you have remembered this. Here we have written, see here, for the first source file we have written file1.tr. For the second source file we have written file2.tr. Both the things I'm going to write, and I am going to give one greater sign. Okay, then I'm writing A1. If I write A1, whatever the tracing files has come here, the tracing datas, it will shift to the A1. It means that all the datas, the tracing values, the tracing datas will move towards your A1. Similarly, for the second one, as I have two source node, I have written 2 times. If you have 100 source node, you write 100 times. So depends upon how many source nodes you have created. Similar process, awk minus f lab3.awk file 2.tr, shift all the files, the data values, whatever is present inside file2.tr towards your A2. Next, what you are going to do? You are going to plot the graph. To plot the graph, you need to write the command as xgraph space A1 A2. That's all. Okay. This sign is also known as output redirection operator. Okay, because it is redirecting the datas. It is redirecting that. Move the files, move the datas from file 1 to A1. Move the datas from file 2 to A2. So this is also a Viva question. If you have to remember, this sign is known as your redirection operator sign. Okay. Once you have done with this, you can see your graph in this way. Okay, you can see your graph. Here I have told you, na, A1, A2. It is not mandatory to write A1, A2. You can write Y1, Y2. You can write your name also. You can write your USN also. No problem at all. Whatever you will write, the insertion operator will work in that way and the graph will plot. Okay. Now suppose you want to see the datas. I have not taken that image actually. If you want to see the tracing value datas from your awk file, you can write vi lab3.tr. Have you remembered this lab3.tr? In the beginning of the program only we have written here. See here, lab3.tr, that values you can see. If you want to see this file1.tr, you can write vi file1.tr. Then this A1 red color line, this datas you can see. If you want to see file2.tr, you can write vi file2.tr. No problem. You can see all the datas. I have not taken that image. You can write and you can check it out. And you can find out all these values. Automatically it has been created. I have not given any x values or y values in my program. Automatically TCL supports all these things and it shows the graph. So this is all about your lab 3 program, that is known as your implementation of an Ethernet LAN using n nodes and setting the multiple traffic nodes and plotting the congestion window for different source or destinations.